Welcome to Science Goes to the Movies, the stories of science and how they change our culture. I'm Lisa Beth Kovetz. We had such an amazing conversation with author and roboticist Daniel H. Wilson and geneticist Dr. Chris Mason that we had to break it into two. So here is the second half of that show. Chris, do you think we're human without our bodies?
So if you take a brain, put it in a jar, there was a Steve Martin movie like this a while back.
Right.
Man with Two
Futurama.
Brains. Yeah, Futurama. You can still be human, you're just a different kind of human. So I think if you really had the complete, cognitive abilities and capacity for memories and future projection and everything you know about yourself, but you're just in a different form, you're just a different version of human. I mean, there's as a philosopher named Derek Parfit who wrote a whole book about this. If you just start replacing, one cell at a time out of your body or half the cells, take your brain and take half of your brain cells and half of mine and swap them. Does that mean we're 50%, 50%, or what is it that defines a human? And he actually ended up concluding that because of all these thought experiments, it was almost more the people you interact with and the environment that defines, a lot of who you are and what you are. So as long as you still had a lot of, I think, the same ability to interact with the world, the aspects that make you the most human and even recognizable to people could potentially be the same.
Just to get really philosophical, this is great. This is such a fun thing to talk about. I've also just read a really cool book called The Ego Tunnel, which essentially describes the brain as a reality machine, right? We have a certain number of senses, we have a certain amount of cognitive capacity, and the brain really constructs this world that we see around us, and it gives us just the information that we need in order to ideally stay alive and procreate and all that. And so if I were going to be uploaded into a machine, I would definitely want to have a world simulated around me. And in fact, there's arguments, people do argue that we're already in that world. And if we're talking movies, then of course, The Matrix is what springs to mind in terms of just give me a really good simulation. I don't want to be a blinking cursor somewhere. That just sounds like a hellish prison.
Right.
That just sounds like I would just type the letter A and just hold it down, right? I'm stuck inside of a computer. Someone kill me, right? But give me an awesome virtual world to live in, and I think I could spend out my eternal days, inside the machine.
I think the book Altered Carbon really, the iteration on Netflix was fabulous also, but the book really talked about that concept of living forever and dying repeatedly, and the darkness that you face when you're not in a body could be terrifying.
Yeah, you'd have to retrain what the mind is used to, but the human brain is really extraordinarily plastic. So I think the ability to live in a or even to live in a box. You think we've talked before about, long trips to Mars or going to another star where whole generations would be born and die on the same spacecraft. You'd have to figure out some way to just survive in a very limited sensory environment.
Yeah.
But human brains are really plastic and they can survive. Even you can do a hemispherectomy right after birth, lose literally half your brain, and those children can survive and even adapt and become relatively normal. Because if you do it early enough, the brain can adapt. It's really, really extraordinarily plastic that way.
Humans are amazing. Humans are amazing. In the movies, robotic and genetic scientists often suffer from the same fatal misstep. Their prized invention, created only to help humanity, was released or weaponized by the military, or in some ways has accidental, unforeseen consequences. Chris, in real life, are geneticists very concerned about accidental, unforeseen consequences?
Yes, so there's many sessions at large international conferences. There's journals dedicated to this idea. There's constant and widespread concern and discussion about what could go wrong, which the examples of which are many. And that one of the first notable conferences was the Asilomar Conference in 1975, where when recombinant DNA technology was first coming onto the scene, it was really a great example of scientists self-regulating and saying, whoa, what if this goes down the pipes and destroys the ecosystem in the rivers and the ocean? What if something really bad happens? So established a series of protocols for containment, protocols for safety and disposal, which are still followed today. So every time in my laboratory we have to do anything with recombinant DNA or gene therapy or engineering of cells, there's special protocols to make sure you don't drink it or just throw it out the window, or I mean, I don't know why you do that anyway, but you do it carefully, is my point. But, and so there's concern and then active sort of self-regulation But what's extraordinary is it's really easy now to do CRISPR. You can order kits on Amazon. You can get, my grandma's doing CRISPR, his high school students doing CRISPR. She's not really doing CRISPR, but she could do CRISPR. It's extraordinarily easy to edit DNA in a variety of ways. You can order everything online very cheaply. So
sure, in downtown Brooklyn, there is a science lab that you can rent like you would rent an art lab.
Like you get a gym membership, you can go get a lab membership. And there's people who do a lot of biohacking, so they try and edit themselves and their cells.
Right. Can I get a cat dog?
Right, not yet. Or I have one friend who really wants a really small elephant. He's been bugging me about this since middle school, and he's like, "Oh, you're in genetics. Can you get me that little mini elephant?"
Well, can you?
Not yet. And so I was worried about cancer and other diseases first, but with me, but people want. But I mean, so this is interesting. The ability to regulate has gotten much harder. And probably the same true in robotics. As the technologies become more ubiquitous and cheap and accessible, it's going to be hard to stop everything. So I think we depend a lot on, the hopefully goodness of most people to not be evil, but we don't have a badge.
We need that badge
system.
Of course, no one's going to accidentally stumble onto an already built army of robotic soldiers, except maybe Obi-Wan Kenobi and the Phantom Menace, but those were clones, not robots. But the rapidly multiplying capacity of computer science has led serious think tanks around the world to focus on the concept of accidental robot sentience. Daniel, to me as a layperson, robots seem really stupid, and sentience seems really complicated. Do you think that it could be accidentally stumbled upon, or is that just the plot of like a really good novel?
Yeah, so in a short, heck no. I'm pretty skeptical of that whole scenario. Having worked in a lab, having painstakingly tried to build robots that worked, that weren't stupid, the idea of it just spontaneously occurring is kind of like the idea of elves coming into the cobbler's shop at night and just making all the shoes. Unfortunately, this is the singularity, as Chris mentioned. It's the idea that you're going to build a machine that's smart enough to build the next version of itself that's a little bit smarter,
right.
And then that machine will do the same thing, and there will be this endless feedback loop that will create this intelligence explosion, and it will never end, and you'll end up with sort of a godlike intellect that's trapped inside of a box. And the problem with that is that there are all these reasons for a feedback loop like that to fall apart and wobble and stop. And all those reasons are why people do science. So I think that in terms of breakthroughs, in terms of suddenly realizing, whoa, we've got a robot today that we never dreamt we'd have yesterday, I think that it's much more likely to come through a combination of existing technologies. So what happens is you've got thousands of people out there working in parallel doing speech recognition, all sorts of deep learning, all sorts of AI applications. They're doing, the motors, the batteries, and all that stuff, and the sensors, the laser rangefinders. Eventually, what happens is someone will go through and cherry pick and grab, 3 or 4 of these really mature technologies and put them together in a novel way that people didn't see coming, that nobody expects. And then suddenly you've got some kind of breakthrough. You've got a robot with capabilities that people didn't expect. And right now, a lot of those different areas are starting to really mature. We take it totally for granted now that we've got speech recognition on our devices, face recognition. This Skype program now has a button I can push to blur out the background, and it's got echo canceling. I mean, these are all AI applications. And they're starting to proliferate out there in little ways. And I think there would be a moment when people will put them together into something that is really surprising and possibly even scary.
Why scary? I mean, all those things sound like good things. Those are all fun things. What makes them scary? If you take out the human concept of somebody misusing them, I wholly understand the idea that someone might take these very aggressive, very powerful technologies and
cover up a crime.
Yeah. Well, sure. I've pitched so many television shows based on it.
Well, we're rehearsing our fears in those things. That's why there's so many of them. But why, at what point does it become the machine deciding? I mean, they seem to have why would they ever think that?
I think it's personal. That's why. I mean, I think there's a general long-standing fear that people have had when it comes to robots, and in particular humanoid robots, because this is personal. Human beings are only good at really one thing. We're smart, you know? We've got little claws, we don't run that fast. In terms of the animal kingdom, we're pretty much prey, except for our big brains. And so now you see another entity coming along that's starting to reproduce abilities that we thought were special. You know, we really thought that painting paintings made us special. We thought that making music made us special. And every time robots gain one of those abilities, we sort of circle our wagons tighter and we go, well, no, only humans can do this though, you know? And there's going to be a day when those those wagons circle down into a singularity, and there's nothing there anymore, and we're going to have to come to terms with what it means to not be special, to have all of our abilities duplicated by machines, and I think that day, that is the root of our fear of robots and machines.
Thoughts?
Well, I guess we'd still, on that day, we'd still have our unique fear of all those machines. So we'd still be afraid of what had happened or something.
There'd be some robot out there that's even more afraid than you.
That's right.
Just better at
we could engineer that. I think it'd be, there's still, I think we should welcome the fact that we would have a day where there's nothing left that's uniquely and truly human, because maybe then that means you could learn faster, do things better, survive in other environments. We'd have more, there'd be more collaborators, if you will, people that are just like us but think like us and could maybe help us, right? So I think instead of having that moment be one of the point of fear, it might be the beginning of where we can actually get more things accomplished as a species, or as like a collaborative species with other things that have taken. If we do it right, they'll have the things that we like about humans: the curiosity, the intellect, and as well as some of the aspects of endurance. Actually, I think in the animal kingdom, the only thing that really defines humans is that we can run the longest in terms of the endurance running, more than, we certainly can't run the fastest, jump the farthest, we're not the strongest. And by some metrics, you say we're not necessarily the smartest in certain environments, but certainly the breadth of our intelligence and the awareness of extinction is still relatively unique. But I'm very curious for the day when a robot understands the sense of extinction, which, as far as we know so far, is unique to humans. And then I think entities act differently when they have that concept. Not, we think about it of personal mortality, but a species level extinction awareness makes us act a little bit different. It helps plans to go to Mars and elsewhere, but it hasn't stopped us from mitigating climate change completely. So it's both good and bad to have at least the capacity, but it doesn't mean you'll act on it.
Just to be fair, that knowledge has motivated AIs in my novels to exterminate large swaths of the human race. The knowledge of the extinction events that we're causing and may cause ourselves,
and Terminator, and you can't blame the machines. And they're like, well, we are, having some problems. You feel like, we're like the drunk uncle who's knocking everything over, and we need a sobriety program.
Well, in Blade Runner, it's that fabulous speech that Rutger Hauer gives when he finally faces death and understands death. He saves his enemy.
Quite an experience to live in fear, isn't it? That's what it is to be a slave.
So that understanding can go both ways, and I think the movies and the science are a good match for each other because you can rehearse it in movies and nobody dies.
Right.
Well, and I thought that was really well said, Chris, about the idea that we'll change. We're not in a vacuum here. As these machines become parts of our lives, they change us too. And there's going to probably have to be a future where people are willing to change themselves genetically and with technology in order to deepen the relationship they have with these machines. Right now, the machines are invited to our party.
Right.
What's it going to be like in the future when we start wanting to get invited to their party, and we are going to need to upload ourselves or get bigger brains or
enhancements?
That's going to be exciting.
Because we'd go to the party and we would just be really boring at that party if it was all really super smart robots that can do everything.
Nobody wants to be boring at a party. Anything that makes some of us more powerful than the rest of us comes with gigantic consequences, and lots of movies are rehearsing that problem. On the genetic side of the problem, there's the movie Gattaca, where institutions feel comfortable denying people opportunity and services because their genetics are not up to par. And in the Marvel Comics series Truth, Red, White, and Black, we learn that the super serum that changed Captain America's DNA was first tested on African American soldiers. Chris, we all want to be better. We all want our children to be better, and we're already really deep in the rabbit hole of income inequality. So how do we prevent Gattaca?
Yeah, it's still one of my favorite movies, of course. I'm a dorky geneticist, so it's right up there. I had it on VHS and DVD, and none of my students know what a VHS is anymore. But the lessons in that movie are really, I mean, timeless, because if you could, in both directions, if you could get to a sense where you can get with 99% certainty what you think someone will be good at or what they'll die from, or their acumen, which assumes a lot of things, but if you can get close to that, people would want to act on it. And so in that society, in that fiction, it really, everyone was at birth was their life was determined. And so, and the motto for the tagline for the movie was, "There's no gene for the human spirit," is that there's some things you can't model with biology or algorithms or regression models, that you can't tease out certain drives in people. And also, some of it has been legislated and actually defended against already. So it's illegal currently, or as of at least 2008, to discriminate based on hiring or firing or health insurance. So that at least the law has caught up a little bit with DNA and DNA testing, but it is still legal to say, well, I heard your dad had Alzheimer's, and I hear you're applying for a long-term care plan, even though you're young and have no risk. Since it's in your family, I'm going to use public information to discriminate and raise your rates. It's perfectly legal. And so there's still some things missing from the genetic discrimination laws that are being worked on.
So let me just clarify, if you do a genetic test on me, you can't use the information. But if you gather information in a wholly unscientific manner,
it'd be legal to use it. Yeah, that's one thing. It's illegal to ask you for a DNA sample. But what's extraordinary is I don't really have to ask you. I could wait for you to get up off the chair and then sequence all the DNA that you're leaving right now, and then that would be enough information to probably make a pretty decent model. And then that would actually be legal because I didn't ask you for it.
That would be legal?
Yeah. It'd be creepy, but it would be
so
legal.
creepy. I'm keeping myself very close.
That's why some people sleep in plastic bags now to prevent that. It's the only way to do it. They need a little, oxygen on the inside. But
I saw that movie.
yeah, right.
Daniel, on the robotic side of the problem, we have the movie Elysium, where super wealthy humans like Jodie Foster have medibeds that keep them perfectly healthy, while poor Matt Damon can't even get his broken arm properly fixed. And in real life, really, a better, expensive, super fancy computer or phone would make my life easier. Do you worry about the long-term effects of robotics on human economic inequality?
Yeah, I'm paying attention to that. Right now we have situations where we have massive manufacturing that's done by these really expensive and complex industrial robotic arms. And, all the fruits of that labor are going to a relatively few people, So you see everyone shuffling in and out. In China, they do the 24-hour work days at the, so that work shifts, so that, you have some shift coming in at 2 a.m. Those people that are going in with 1,000 of their friends into a warehouse are not really sharing the benefits of all that infrastructure. So, I absolutely pay attention to that. People often try to explain that away, saying, every time you create these new technologies, you also get all these new jobs. Where are all the horse and buggy drivers and things like that? And that is absolutely true. And that's part of why I have some hope about this. Just thinking about robot arms. So the reason they're so expensive is because they're high tech. But what happens as technology matures? We've already started to see some companies that are selling robot arms to individuals. And I really like this idea. Because in the United States, it seems like everyone's obsessed with, I want to be a billionaire. Like, I want to create a company that makes $1 billion or $100 million. Well, as it turns out, to be really wealthy, like more wealthy than almost everybody else, you don't need $1 billion. If you had $1 million, you'd be doing great. And so if you imagine a future where you have some awesome earrings that you make and you sell them on Etsy, right? and then you save up 15 grand and you buy a high performance robot arm that lets you mass produce your individual creativity, this thing that you did on your own, and you keep all the fruits of that labor. Then now I see it as democratization of that technology that allows individuals to, to rise above the situation where they're working for pennies, and making some other person a billionaire. So I'm hoping that as that kind of technology spreads out, democratizes, individuals are going to be able to use it to reach bigger audiences and, put their creative ideas out into the world and make a little bit of money, and not necessarily $1 billion.
Chris, your lab has a 500-year plan for the survival of the human species. When you look down the lens to 2519, do you see us using tiny robots to repair our bodies?
Absolutely, and we do some of it today to deliver drugs in some cases, or to even sequester them and for delivery later, or even just to move cells in different places or to repair them. So, I think if you look out 500 years or even just 100 years, we had a scant knowledge of the fundamental components of human biology or even immunology only 30, 40 years ago, and now we can actually know what's there, know how to engineer it and target it. So I think the plans for going to the moon and Mars and beyond, it's going to be a collaborative joint effort. It's going to have to be. Like, we're going to depend on the robots and they're going to depend on us, and we're going to make it together, or we're not going to make it at all. So I think both at the nanoscale and at the gross sort of even rocket level scale. So I think it's they're extremely complementary.
Chris, I love this idea of people filled with robots inside of robots flying through outer space.
It's going to happen. I think it's going to, well, because one of the things we see, and we're having some study that's coming out soon about this, is astronauts get irradiated and it creates DNA damage, and the body is not yet capable of repairing all the damage from the insults and injuries of spaceflight. So
really,
what if we have really two options. Either we engineer the genome to be more active and improved and have extra capacity to repair itself, or we have robots help us, or both. So I think we would want to make sure that everyone can survive the trip. There's also within the space research community a lot of people who are just robots, and they say we're not going to send humans. Yeah, we're very adaptive, but we're really fragile. So why not just send robots to faraway places? Because they don't have to worry as much about radiation. Or if they do, they do get irradiated, but you can reprogram the memory so it resets even when that happens. And so that's harder to do with the human brain. So
it's going to make a lot of astronauts really sad.
Yeah, I know. They want to go, but they might need an exoskeleton. It really is, I think, a joint effort. It's going to have to be.
Maybe they'll experience it through the exoskeleton.
Yes, yeah.
Like a virtual reality thing.
Yeah.
Daniel, knowing what you know about real-life robots, do you think these infinitesimally small nanobots could actually be built?
Yeah, no, like Chris said, they absolutely are being built, and it's the early days right now. I mean, if you go up 1,000 times in scale and look at micro robots, there's already a lot of really cool work where they managed to basically hitch rides on bacteria in order to locomote in that. It's a really unique environment, whenever you get down to that scale. But, if you're a roboticist and you're looking at the world, all your knowledge about how to build robots is a hammer, and everything out there looks like a nail. So whenever you start looking at micro scale environments and nanoscale environments, building robots out of individual atoms, I mean, these are all challenges that people are willing to take on, and for the best reasons. I mean, we're talking about curing cancer here, so that's I can't think of anything better to do with your time if you're a roboticist. So, yeah. Although it does not sound that appealing to be filled with tiny robots.
It sounds kind of itchy, yeah.
Yeah, it does.
Well, so will we change our bodies to suit these robots?
Yeah, well, so selection and evolution are always occurring, and so I think if it gets widespread enough and people start interfacing with robot devices, if it happens consistently through generations, it'll create a selection pressure that maybe there'll be people that start, the human body and physique might adapt towards, interfaces or implants, or even just having. I mean, there could be, so there's ways to control the immune system, and maybe people have a version of Benadryl from nanobots, so you'll get a little bit of inflammation, a little bit of itchiness, but just take this pill, and you'll be fine, so I think it'll be a constant back and forth.
another aspect of that question that makes me really excited is also that people aren't all the same, right? So I mean, there's lots of people who have various types of disabilities. They, even that word is kind of a misnomer. They just experience life with a different set of parameters than most other people. Whether you have hearing loss or vision loss or mobility loss or whatever, whether you're neuroatypical. And I love the idea that different types of people will embrace different types of robotics technology to really excel in different ways, right? And it would be, interesting to see a future where people don't really consider, disabilities to be the same sort of drawbacks that we consider them now, and they are actually really potentials. They really create a potential for really unique abilities and really unique skill sets. So. Yeah. I would love to see that kind of, and that's how people are starting to think too. I think as time goes on.
So with this great overlap between robotics and genetics, is your future company going to be Mason Wilson Industries or Wilson Mason Industries? Where should I invest?
Or a Genobot or RoboGen or Wilsona Masonian or something.
Yeah, I'm not. As long as he gives me access to the blood cleaning robot,
especially after a night at the bar.
The hangover robot. Guys, thank you so much for spending time with us.
Great, pleasure. Thanks.
It's fun. Thank you.